Hey class, if you missed the lesson yesterday, today I will be going over using proportions to solve geometry problems. Okay, so this is 6.2 in your book. Let's get started. So, if we take a look, we are still in our similarity unit, but this is the 6.2 section. So, a review of last time, the main property we covered was the cross product property of proportions. If you have A over B is equal to C over D, then AD is equal to B times C. Okay? The numerator times the denominator, and the denominator times the numerator, if you take the cross product, then those are also equal. So if you have 2 over x is equal to 5 over 8, right? 2 times 8 is equal to 5 times x. And over here, if you have AB to BC is 3 to 8, and you know that AB to BC is like this, you can actually cross multiply them and get equal proportions. Okay, so 16 over 5 is x. And over here, when you cross multiply, right, you get P24 is equal to 3 over 8. When you cross multiply, you get 8P is equal to 72. You divide by 8, you get P is equal to 9. So this should be a review. If you didn't get that, there is a slower explanation in the last video. Check that out. Okay, so today we are going to talk about 3 more properties. All right, one of them is called the reciprocal property. Okay, and essentially, if the two ratios are equal, then their reciprocals are also equal. So in other words, if I take A over B is equal to C over D, then B over A is equal to D over C. If I flip them, then they're equal. A numerical example of that would be 2 over 10 is equal to 12 over 60. If I flip them, 10 over 2 is also equal to 60 over 12. Now, it's important to note that this is not the same as this. The only thing that this property is saying is if this is true, this is also true. Notice this is equal to 1/5 and this is equal to 5, right? So they're not equivalent. It's just that when you flip it, the proportion, like it's still a proportion and it's a legitimate proportion, okay? For number 2, same thing. If you interchange the means of the proportion, then you form another true proportion. So in other words, if you take the B and you swap it with the C, you swap places with the C, or you take the A and you swap it with the D, you are still going to get equivalent proportions. So here's an example. If you have 2 over 5 is equal to 40 over 10, then, if you swap the 5 and the 40, 2 over 40 is equal to 5 over 100. Once again, this proportion is not the same as this proportion, but these two are still equal, just like these two are still equal. Okay? Also, in a proportion, if you add the value of the ratio's denominator to its numerator, then you form another true proportion. So if you take the B value and you add it to the A, and you take the D and you add it to the C, then you still get proportions that are equal, okay? So this is 7 over 4, and that is 175 over 100. And as you can see, those proportions, if you simplify them, are also equal, okay? If you have any questions, make sure you email me, okay? All right. Using the properties of proportions, consider the following diagram. MN RS is equal to NP over ST. So NP over ST, MN is equal to, MN RS is equal to NP ST, okay? Write 4 different proportions. Okay, well, the first one is just the one that they give, right? This over that is equal to this over that. That's the most basic one. This is the one that you should be able to figure out pretty easily because it's given to you, okay? Now, the second one is, okay, well, what if I decide to take the reciprocals? 10 over 8 is equal to x over 4. That is also equivalent, okay? Those are also equivalent. I could also take this and move it here, and this and move it here, and I would still have equal proportions, right? So 8 over 4 is equal to 10 over x. Okay, oh, actually, wait, what are they? Yeah, they moved the 4 and the 10. Okay, so you can interchange the means, all right? And last but not least, you can add the denominator to both. So you get, oh, this should be up here, sorry. When you add the 10 to the numerator, you get 18, and you add the x, you get 4 plus x, and you get another equivalent expression. Okay? Okay, cool. So, how do we use it to solve problems? So in this diagram, it says BD, okay, to DA is equal to BE to AEC. Now, I don't actually like the way that the book solves it, but since I don't have the ability to write within this screencast, I'm going to go with it, okay? And they are trying to illustrate a point here, okay? So what they're saying is, okay, find BA and BD. So the way that they do it is this. BD over DA is equal to BE over EC. So they use the property of adding the denominator. So they take the DA and they add it, the EC and they add it. This is unnecessary, but that's the way they did it. Okay? And so it's really interesting, right? They go 18 plus 6, right? And this is x over 3. 18 plus 6 to 6 is equal to x over 3. Okay? Then what you do is you cross multiply. All right? Cross products. You get 6x is equal to 3 times 18 plus 6. Okay? And what you get is when you divide by 3 and then you divide by 2, you get x is equal to 12. Okay? And once you get x is equal to 12, well, you know BD is 12, and if you add DA, right? Oh, sorry. Oh, yeah. If you know BA is 12, then you know that BD must equal 9. Okay, when you take 12 minus 3. So that's how that works. Okay? Again, I will, next Monday, I will be doing a live stream reviewing all of your homework. I forgot. There are a couple more problems. My bad. So, the blueprint shows a scale drawing of a cell phone. The length of the antenna on the blueprint is 5 centimeters. The actual length of the antenna is 2 centimeters. What is the scale of the blueprint? Okay? So when I look at this, right, the length of the blueprint is 5 centimeters. Okay? The length of the antenna is 2 centimeters. Okay? So what they're trying to say is, okay, well, what is the ratio of the antenna to the blueprint? Okay? So what you have is what, 5 centimeters to 2 centimeters. If you simplify it, you actually get 2.5 centimeters to 1 centimeter. That's the scale of the blueprint. Okay? The same thing here. The scale of the map to the right is 1 inch to 26 miles. Find the actual distance from Pocahontas to Algona. Okay? When you use a ruler on the actual map in the book, you actually find that the distance on the map is 1.25 inches. So if you set up the ratio, 1.25 to x miles, it must be equal to 1 over 26 miles. Okay? When you cross multiply, you get x is equal to 26 times 1.25. So x is equal to 32.5. The actual distance from Pocahontas to Algona is 32.5 miles. Okay, so I apologize for the length of this video, but I was trying to keep it short. Here is your homework. These are the 4 problems. Please turn them in on Google Classroom. They are due April 17th, Friday. Okay? Have a good day, everyone. Thanks.